right, good morning, everybody, and welcome to today's webinar. This is the third webinar in the six-part webinar series by the SunSpec Alliance and sponsored by Port Labs, a energy incubator and accelerator based out of the Bay Area. Go to the next slide. Today's webinar is going to be focused in on looking ahead to the adoption and deployment of IEEE 2030.5 and the ongoing standards development area work continuing in this area. In the previous iterations of the first two webinars, we provided a current look at the DER industry and the activities in the SunSpec Alliance. The last one with metal, we looked at the past and the history. And now as we move forward in this webinar series, we're going to start looking at the standards, the protocols themselves, and the road ahead. And I just realized shortly before this webinar series, the road ahead, that's a cheeky little pun there, because we are going to be focusing in on the V2G applications for 2030.5. Today's webinar is going to be presented by QualityLogic. QualityLogic has been a longtime member of the SunSpec Alliance, one of the authorized test tools for SunSpec certification programs. Their tools used by virtually all of our authorized test labs. Has been leading the way for years in the area of 2030.5 test tools. So we're excited to have them share their perspective and their expertise with you all today. Go ahead and go to the next slide. Before I pass it off to James, go ahead and read the antitrust and intellectual property provisions. All SunSpec meetings are conducted in accordance with the SunSpec antitrust policy and intellectual property provisions defined in the SunSpec member agreement. This agreement can be found at the following address. SunSpec strictly prohibits market participants and their employees who take part in these activities from using their participation as a forum for engaging in practices or communications that violate antitrust laws. Confidential or proprietary information should not be discussed in open session. Please contact SunSpec management if you have any questions. Last couple notes before I go ahead and pass it off to James. This meeting is being recorded, so afterward you'll be able to find that on the SunSpec website. The deck will also be made available. And also, because this meeting is being held on Google Meet, you will have the ability to unmute yourself, but we do ask that you keep yourself on mute until the end when there will be time for question and answer so that we can get through all the material and keep background noise to a minimum. If you have any questions or comments throughout the presentation of the material, please do go ahead and enter those into the chat, and we'll take some time, like I said, at the end to address those questions or comments. So with that, I'm not going to hold this up too much longer. I'm going to pass it off to James Mader, who is the CEO of QualityLogic. Take it away, James.
Great, thanks, Dylan, and we're pleased to be here. We've been working with 2030.5, I think since 2012 is when I recall we first got involved with it. So I'm going to introduce us and introduce our role with 2030.5. And then Steve Kang, who's our general manager, is going to talk and do an update on the standard. He's very involved in that. Talk about a little bit about the history and mostly about what's the current state of the standard, what's being done. And then the last part is the SunSpec SAE J3072 profile that's being worked on. Then I'm going to give a bit of a report from the V2G forum, which was held last week in Detroit, Michigan, and I'll talk about how does IEEE 2030.5 fit into this end-to-end vehicle-to-grid system in North America. Talk a little bit about J3072, UL 1741 SC, and 15118-20. So those people who are in the EV area, you'll know these terms. Others, I'll try to do a little bit of description of what they are. And I'll do some comparisons of them and then summarize. So our two presenters today, Steve Kang is our general manager and also runs the engineering. He is a real expert in IEEE 2030.5 and IEEE 1547, California Rule 21. He is currently working on a CSIP, the Common Smart Inverter Profile Update. He's part of the working group. And we also just recently introduced a global support, global grid code support. So 1547 is one of many grid codes around the world. To us here in North America, it's the important one, but every place else has their own version of grid codes, and we're supporting that in our tools. Steve teaches our classes at 2030.5 and 1547, and has just finished traveling to Asia and then Europe, and then here in the US, teaching these classes. So I'm Director of Strategy for QualityLogic, and I've been doing work in the whole area of smart grid standards and interoperability, and how do you mature ecosystems so they're actually interoperable. I like to give talks and papers on this, but I'm also a member of the UL 1741 SC working group, the SunSpec J3072 profile, and something called Task 53 work group. And I co-founded and co-chair the VGG forum that we're going to talk about. So what's our role? So we focus on compliance and interoperability testing of, well, here I got V2G, but it's also DER, right? So anything related to putting energy back into the grid or managing distributed assets. So we work with those standards that the utilities adopt and help the industry implement those standards and ensure that they're compliant and interoperable. We're in sort of a unique market position. We're the first ones to bring to market actually 2030.5 and 1547. And these turn out to also be vehicle-to-grid test tools, or the start of most of the test tools needed from a software testing standpoint. Our tools focus on managing the hardware in an inverter testing lab or a V2G test lab. And we're actually quite recognized on a global basis for this unique position. We work with the certification labs, again, globally. So there's some names here, but these labs all have, they have branches in probably 2 or 3 places in China, in Korea, Japan, Europe, US, and we work with most of those branches. They're customers of ours. We train them and we equip them with our tools. And we've really been focusing last year on vehicle-to-grid standardization. Like I said, I co-founded the VGG forum. There's something called the IEEE Task 53, which is really interesting. If you don't know about it, you probably want to know something about it. I'll talk about it a little bit later. And we're quite engaged in the VGG standards in the US. So, and we partner with the hardware suppliers. So if you think about a inverter test lab, you need a grid simulator, power analyzer, DC power source, etc. We work with them. And so we're partners with them, not competitors with them. Our customers span the range from utilities to the EV OEMs and those making inverters and those making charging stations. And in the middle are the people that aggregate these resources for utilities. Now we call them aggregators in the DER world. I call them charge network operators or charge point operators in the EV world. And for each of these groups, we provide training and do some consulting, and then test tools that are relevant to their needs for meeting mandated standards. And then we also work on interoperability where we can. So here's kind of an overview of our product portfolio that we're offering to the market today, including some that we're working on or planning to. And they fall into 4 buckets: protocol compliance test products, functional safety compliance products, test products, interoperability, and then protocol stacks. So the first one we did back in 2013, I think, was OpenADR certification tool. We are still partners with the Alliance, and we still maintain and support that protocol and train customers who want to learn about it. The next one we did was IEEE 2030.5. And when CSIP came along, Common Smart Inverter Protocol, we were the first to come to market with a tool to test that and certify it, and became a partner with SunSpec in their program. Australia adopted a version of CSIP, which Steve will talk about, and we also support that in our test tools. We support somewhat today the first version of the IEEE 2030.5 J3072 profile, and we'll be working on updating that as we update the standard itself, the profile. We recently introduced a SunSpec Modbus compliance test to help with the interoperability issues in smart inverters that use SunSpec for their interoperability protocol. And for all of these, we do training. The safety side, so this is what started as a, what's called UL 1741, which is primarily a safety standard to ensure that inverters or diesel generators, anything putting power into an electric grid in the US, it ensures that it's safe. It's evolved to be a much more sophisticated standard that we support now, and we supply the tools that are used globally for testing and certifying to that standard. There's something called UL 1741 SC, which is hopefully going to be published by the end of this year, and I'll talk about it a little bit later. Then we just introduced support for it's called the European National Grid Code 50549, and the support we introduced also enables adjustment of the parameters to meet most of the European countries and Great Britain for compliance testing. And we do training on the grid code standards. We got involved with the charging world. Anyone who has an EV knows that interoperability of fast chargers is a problem. And we got interested in it and developed an analyzer, which is used in the marketplace. That was our first foray into this domain. And we also, and from an interoperability standpoint, we also support all the protocols that are named in IEEE 1547. We will be adding, we're starting work on adding to our protocol, our support for the grid code testing, something called OCPP 2.1 and ISO 15118-20 Amendment 1. I'll touch on these a little bit later. And we do training on all of these, of course. And then this year, we're starting, we've been working on what we call an EV interoperability test platform that's open source software and low cost hardware. So anyone who's building EVs and wants an interoperability test platform, this will be really the lowest cost one on the market, and hopefully a standard one when we get it out in the market next spring. Then recently, this year, we were able to offer the industry protocol stack for IEEE 2030.5 client, and we're working on a server stack that will be available later this year. So with that, Steve, I'm going to turn it over to you.
Okay, great. Thank you. Thank you, James. I am recovering from a cold, so hopefully my voice will be okay for most of you, and you can hear me okay. So next slide, please. Yeah, let's do some historical memory lane here. Many of you, I see, have been involved with 20.5, and some of you may have been involved with 20.5 since the beginning of its creation, which was known as Smart Energy Profile 2.0. So sometimes you hear in the industry SEP 2.0, And that's basically the creation from the Zigbee Alliance that took the SCP 1.0 technology, which leverages its own wireless mesh network along with what they call cluster definitions that represents various energy-related use cases and functional use cases, and re-architected with open internet standards. So SCP-2 was created late 2008, 2009 timeframe, and we've been involved with the technology since then. So it's interesting and amazing that it's been around for that long, and happy to see such a wide adoption of this technology. So in 2013, the standard was handed over to IEEE, who renamed it as 2030.5, which is what most all of us know and refer to today. So 20.5 is a HTTP-based protocol that leverages TLS 1.2 for encryption and so on. And then on top of HTTP, data that flows back and forth is XML, which is mandatory data encapsulation. And then EXI is optional. So to this date, it's pretty much an XML-based protocol. There's very little use of EXI at this point, mainly because it's optional. And then on top of that is where 20.5 sits. 20.5 standards defines many different functions, and original creation was geared towards managing energy devices within a premise, like a building or a home, such as smart thermostat, smart meter, smart appliances, smart inverter, and so on. And since then, because of the CSIP and Rule 21 adoption, it has taken the standard outside the home and premise, where the communication is done with a utility server over internet or VPN or other connection that marries the two. Since 2013, there has now been 2 versions of the standard, one in 2018, and then last December, the 2023 version was introduced. So there's now 3 versions, but pretty much at this point, because the Rule 21 mandates the use of 2018, CSIP is based on 2018 standard, and all the current SunSpec certification is based on 2018 version at this point. So next slide, please. So let's briefly talk about what CSIP is, and then we'll get into what V2G profile is. CSIP is one of the most popular profile that is used for communicating and managing DER devices via utility. So CSIP supports implementation of clients as well as servers to meet the Rule 21 communication requirements. California Rule 21 is a interconnection requirement mandated by CPUC for the 3 IOUs here in California, and then also other utilities such as SMUD and other utilities elsewhere in the US and even outside the US uses CSIP-based protocol to manage these devices. Clients are defined as 3 different types at this point, and there is being work to expand that in future version of CSIP, which I'll also talk about. The 3 client types are a direct inverter, an inverter that natively can speak to RAV5 or CSIP-based protocol. And then you have an EMS, which manages multiple assets, but it manages it, and then EMS system controls the different inverters, and then it in turn receives signals from a utility server. And then third category is an aggregator client. Aggregator client is a third-party aggregator company typically that has contract with homeowners and building owners and so on, and then manages different assets through that. And in the aggregator case, all the managed inverters that aggregator manages can be controlled by the utility server, where the utility server can potentially assign different functions and controls to individual assets. And the communication and handling is done by the aggregator itself. And of course, the utility manages the server by providing the capability and controls through the server, where the clients come in and gets those signals by using the CSIP-based protocol. So CSIP was created to create a profile or a subset of the 20.5 standard. So those of you familiar with 20.5, it has a lot more capabilities than you need for Rule 21 support. Definitely, it supports DER use cases, which is what Rule 21 needs, but also supports other functions like demand response, pricing, messaging, energy flow reservation, and so on and so on. Australia, quite active in the last few years, and they originally adopted the CSIP-based standard, but they expanded its capability because they have different use cases in Australia. For example, they have a solar emergency backstop where in case of too much active power generation from the DER devices, there's too much on the grid, so they send out a signal for these devices to stop generating power. That's one of the popular use cases. So Australia community have been very, very active in developing their own set of standard called CSIP Australia. And then there's a lot of participants in their own set of working group that develops that set of standard. There is a Australia standard that is based on CSIP Oz at this point, which is what the community in Australia is moving towards. So the current for CSIP certification, OEMs receive certification by developing CSIP compliance systems. And then they go through SunSpec CSIP certification through one of the labs. And as James and Dylan mentioned, CSIP certification, all the labs use our test tool. And the best formula for success is for the OEMs to use the same test tool during development, so it ensures their compliance during development, which is really where you want to make sure that you are compliant. We also offer a 2-day technical workshop that I've been teaching since 2013, and had the pleasure of teaching many companies around the world in understanding the technology. So if you have not taken this class, I encourage you to consider it, because we do go over the standard in much detail, and it's very useful to understand the technology. And it goes OEMs, utilities, labs, utility, and other folks who have a need to either use it, develop it, deploy it, and so on. This is what the technical workshop is geared towards. Current CSIP certification is based on 2.1. So next slide, please. So just briefly, as I said, there's 3 different clients. What's circled in red are the systems that must be certified to be CSIP certified. And SunSpec website currently has probably 100, if not more, at this point, CSIP certified systems. So congratulations to the industry of getting there. And it's really exciting to this wide adoption. So the first box on the top is Smart Inverter Control Unit, which represents an inverter that natively talks to the utility using SunSpec CSIP certification. And you don't necessarily have to have a gateway in front of it, but you could have the communication module as part of the hardware of the inverter system itself. They're treated the same. It's one entity, what's called end device that utility server presents. And then the second is a generating facility EMS, which manages multiple inverters that are owned by the same entity, like a building or a campus and so on. And in that case, utility server sees it as a single end device to control. And the third is an aggregator. It also manages multiple systems, but each has a contract with the aggregator. So it could be mine, could be each of yours that has a contract. In that case, utility server can target each of the managed inverter as a separate end device and so on. Next slide, please. So just briefly, 3 different versions of the standard. 2013 is the original version that started this whole standardization. Functionally identical to the original Zigbee creation, which is called SAP2. And then in 2018, which is what all the CSIP certification is based on at this point, including CSIP Australia, 2018 introduced new functions incorporated from IEEE 1547 and other related standards. Many different functions were added to the standard, such as voltage and frequency write-through functions, connect, disconnect, cease to energize, and so on. And then polling and post rate, where it can be adjusted by the utility, that was also added. For the sake of time, I'm not going to go through each of these. You have reference to this. And then in our workshop, we actually drill into each of these standards in detail. In 2023 version, that's the next major version, that the working group worked on for many years, and it was finally published in December of last year. 2023 version also added new functions, including the CSIP Australia functions. We incorporated those functions into the new standard, and then event rules were added, so that quite a bit of exciting event rules. Now there's events can be resumed, which was not the case in previous versions. And then some of the antiquated, obsolete controls and functions were deprecated. And then based on that, that also kicked off the creation of the IEEE 2030.5.1, which I refer to as CSIP 3.0. Next slide, please. So where we are today, current 20.5 standards. So CSIP 3.0 working group, which is known as IEEE 20.5.1, was formed, and it's led by Gordon Lum. Gordon actually is on a jury duty, so I was actually going to invite him to this workshop, but he's not able to attend. But he's doing a great job leading that working group. Many of you are participating in that working group, and we're also always invite new folks who are interested in participating in that working group to volunteer. I am the secretary, so if you're interested in joining that group, please contact me, and I can provide more information about joining that. So the goal is to develop the next update to the CSIP specification. And there's been a lot of working group meetings in the last few months to talk about what does that look like and so on. So the current direction is to define the minimal base CSIP device profile. And then based on the base, minimal base, other profiles will be created to address specific use cases and regional grid codes, such as Rule 21, 1547, perhaps CSIP Australia, and other related standards. In addition to the CSIP profile, which again is one specific profile to meet DER use cases, but 23.5 base standard has many more capabilities. And because of that, there is also a SunSpec metering server profile that can be implemented by a smart meter. In fact, Itron has a meter that supports this SunSpec metering server profile. In addition, there's a V2G profile to support the communication of V2G functions to support discharging, right? So as the electric vehicle discharges, it's not only providing active power back to the grid, but if you have to meet 1547, you also have to support reactive power back to the grid, support functions like must trip, ride through, etc., etc. So I think I see some of the folks on Australia in this seminar. They've done a really great job of extended the standard to support their use cases. As I mentioned, they have a solar emergency backstop and other consideration. Primarily, CSIP Australia is about currently providing site-level import-export generation limits. And in addition, they have their own identifier called National Metering ID, NMI. So they're also doing work to incorporate other new functions into the standard, such as pricing, and also new functions that are made available in the 2023 version. Next slide, please. So I'll briefly talk about SAE J3072. So what is this profile? It's to support V2G AC, where the inverter is actually at the electric vehicle rather than the charger, which is the case for DC chargers. So why is this needed? There's a national policy, Energy Policy Act of 2005, which requires any device that can generate active power that is interconnected to the grid, which includes EV charger and electric vehicle in this case, they need to meet the requirements of 1547. So from a communication protocol perspective, this was created because there was no protocol that supported the full 1547 functions to be communicated between charger and an electric vehicle. So the SAE J3072 profile, which is a SunSpec profile, right now there's a version 1, but there is an active working group working on the next update to that standard right now. So this J3072 is meant to be used between an electric vehicle charger and an electric vehicle to support the vehicle to do its functions. All right, so next slide, please. So just briefly, yeah, this is another profile that uses the underlying IEEE 2025 standard. If you look at the table on the right, it uses much less functions compared to, for example, CSIP. So you have device capability and so on, end device, mirror usage point, DER, response, subscription notification. It also uses MDNS discovery, which is part of the standard as well. So as an electric vehicle comes up and tries to connect with the electric vehicle charger, you use MDNS discovery to find out who the charger is, who the server is, and communicate through it, and so on. Next slide, please. So there is a version 1 specification which SunSpec Alliance published fairly recently. So all of you should have a notification of that standard. There is an active working group right now working on any update to the profile based on the update of the underlying SAE J3072 profile itself, and then potentially leveraging some of the functions in 2023 version, such as default DER control resource, which in the new version of the standard supports clients sending responses to it, which is very useful for utility to track what the individual vehicle is doing in response to understanding what those controls are. So we're always looking for volunteers. So if you're interested in that for this particular working group, please contact the SunSpec Alliance. If you're interested in the CSIP 3.0 working group, please contact me or Gordon, which is CSIP@IEEE.org. And if you're interested in contacting me, I think after the workshop, there'll be an email that's sent out to contact us. So with that, I think hand it off to James.
Okay, thank you, Steve. So now we're going to talk about vehicle to grid, V2G. So I'm hoping that a number of people in the audience are interested in this area, because that's what we're going to focus on. So last week we had the 6th forum, what we call the V2G forum, which we started about 3 years ago. And this was at a facility called ACM, which is the American Center for Mobility in outside Detroit. And it's a perfect place for it. They've got a 90 megawatt substation with Detroit Edison, and they're focused on moving the EV industry forward. And so it's a great play, and so they're great hosts, and we're working with them. So I'm going to do a little primer on V2G. So first of all, as a reminder, if you've got questions, just throw them in the chat, and we'll try to get to them when I'm done here. And then, this is a topic that we've got a half-day workshop we do just as an overview of EV standards. And then, we can spend do a 2-day in-depth workshop diving into the details of the standards. It gets a little complex, but what I'm showing here is something called V2G DC, which is where the integrated inverter is on the EVSE itself. The EVSE is electric vehicle supply equipment, so most people know it as a charging station. And what I wanted to show here was where 2030.5 plays a role. So first of all, 2030.5 is probably in North America the protocol that utilities will use to communicate to a charge network operator or aggregator. From there to the charging station, if you're talking about communicating grid code settings and getting grid code information for managing DERs, it's right now 2030.5 is the only standard that really supports that well. You could do it with SunSpec or DMP3 also. There is something called OCPP. It's called the Open Charge Point Protocol from the Open Charge Alliance in Europe, in the Netherlands. It's also a IEC standard, and they've released a version 2.1, which can carry all of the messaging required for V2G in North America. But it's just been released, and it's not mature like IEEE 2030.5 is. And then on the inverter itself, there's a requirement to meet the interoperability requirements of 1547. And so IEEE 2030.5 is one of those, along with SunSpec Modbus and DMP3. There's another form of vehicle to grid, which is where you put the inverter on the vehicle itself. And we call this vehicle to grid AC, meaning that the charging station is probably a level 2 AC charging stations where it's passing power through, and it does not have the inverter capabilities to manage grid interconnection requirements. However, it is an important piece of doing V2G and AC. So here you have the same situation with the utility to the network operator and the network operator to the charging station, but you have a new element, which is because the inverter's on the vehicle, you've got to get the grid code information and the management to the vehicle itself. So today, the J3072 specifies, you saw the matrix that Steve put up. It has a matrix, but the only one that's really being developed at this point is IEEE 2030.5. And that's what we're doing with the J3072 profile working group, and that's what we're using for the in the standards today. In the future, there's something called 15118-20 Amendment 1 SAE version, a North American version, that it will be released and can do the grid code management of these EVs. So that's important to note. So the UL 1741 SC also has to be able to communicate with one of the 1547 interoperability standards, IEEE 2030.5 being one of them. So when you look at V2G, I try to simplify it. There's 4 architectural layers: the utility layer, the CNO aggregator layer, the charging station, and the EV. So it's just an easy way to think about what comprises V2G AC. And there are 3 communication paths. Now we've got between the utility and the CNO, the CNO and the charging station, and the charging station and the EV itself. So keep that in mind when we're talking about the standards here. I put together a table to help people understand what certifications are available today and what certifications need to be done in order to support V2G. So I've got, the utility, the CNO, and then both forms of V2G, whether it's DC or AC. And I've got check marks where IEEE 2030.5 server needs to be certified or could be certified. So I've got some footnotes here that the certification may not be required if it's certified to OCPP 2.1. So that's still to be determined. And then a 2030.5 client, same thing. The OCPP 2.1 server only applies at the aggregator, and the client only applies at the EVSE, in both cases here. So an ISO 15118-20 only applies between the EVSE and the EV. So you can see in both cases. So we don't have the standard finished and the certification done yet. For SAE Amendment 1 and the J3072 profile will also be required as a protocol test between the two. I know this is a little confusing. Again, if you want to dig into it, we're happy to help. Then you've got some safety functional standards that only apply at the EVSE and at the device level. So you can see where 1741 SB applies just to the DC EVSE, and the new one, 1741 SC, which we expect to be published this year, later this year, only applies at the EVSE itself, the charging station. And then J3072 is a functional and communication certification for the EV itself. Just kind of for fun, I put together some slides for the V2G forum last week. I was interested in the question in some questions. But first, here's a slide from a partner of ours, NREL, National Renewable Energy Lab, which is building a V2G AC standards testbed to validate that the new UL standard can be tested. And our friend Yuki did this slide. I borrowed it, and it just shows what's published, what's in draft form, and what's not written yet in terms of the key standards. And you can see that IEEE 1547 informs the key standards for. I should have had it go to 15118 also, but it informs all the key standards there for V2G AC. Then I asked the question, I was curious, and so I asked ChatGPT, okay, so what are the advantages of V2G AC versus DC? And it came back with a really simple answer. It said cost, right? So it actually came back with a lot of detail, but this is a summary of what a 15 kilowatt charger would be at a residence. And you can see the AC estimate around 8,300, the DC 17.5. So there's clearly a reason to be interested in V2G AC because of a cost differential. Then you look at where does V2G AC apply? The biggest, the biggest use case is residential, where you typically have level 2 AC charging. But you can also imagine long-term parking, an airport parking garage or something. And then you've got the workplace and fleets, which are more DC oriented. But then you ask the question, what's the potential from a V2G standpoint? Where is that potential? And interestingly enough, the residential V2G AC really is orders of magnitude greater than anything else. And this is why there's so much interest right now. We're seeing a lot of interest globally in this, in doing this kind of vehicle to grid. So Rule 21 in California is being reopened to deliberate on how to deal with V2G AC. There's a new standard that's about to be published by UL, which treats a combination of a vehicle and a charger as a black box, UL 1741 SB system. It just treats it like it would a solar inverter or storage inverter or something. And as long as you've got that combination in a garage someplace, then it can act as a bidirectional feed into the grid. But the real focus is on, and it's sort of a stopgap measure, because think about it for a while, and there's some pros to it, but there are also some cons to doing it this way. So the real focus is on UL 1741 SC, which is defining the requirements and the testing for the charging station that will be used in this application. And then that's a companion with SAE J3072. And we expect them to be added under Rule 21. So one of the interesting things, and these are comments from Southern California Edison that were presented last week, is raising the question, so supposing the utilities decide that it's okay to use OCPP 2.1, even though it's not a recognized 1547 interoperability protocol. So if they decide to recognize that, why should they then require certification with one of the other protocols? So that's going to be a really interesting discussion going on at the Smart Inverter Working Group and the PUC. And they're also proposing some rates, tariffs, so that they can actually pay people who are doing vehicle to grid. This is my final slide here. I'm not going to go through it in detail. If you, I think these are available. you'll be able to see this. I tried to do a contrast between 2030.5 and OCPP 2.1 and ISO 15118-20 Amendment 1. The big thing to remember about these is that 2030.5 is a good communication protocol for all the segments in V2G. OCPP 2.1 or OCPP in general is really focused only on managing chargers by an aggregator of chargers or a network operator. And the 15118 is only focused on the communications between the charger and the EV. So you always have this translation required. So there's good information here. So I'm going to end it with kind of a summary, trying to show where IEEE 2030.5 fits into the ecosystem of both DER management and the V2G management. And you can see that, 1547, defines, identifies 3 different protocols. One of them being IEEE 2030.5, which is quite popular, but a lot of SunSpec certifications are done with that also. The same thing applies actually to the inverters in V2G. So, but in V2G now, you also have some competition with OCPP 2.1 and the 15118. So that is my summary and conclusion, and I think that's it. Let's see if we've got any questions.
Yeah, awesome. Thanks so much, James. Really informative. We got quite a few questions. We got a few questions in the chat we'll get to. I did just want to take one quick second to mention that as a result of the one of the outcomes of the V2G forum last week, it does appear that SunSpec will be hosting the development of the 2030.5 profile for ISO 15118 for the V2G AC application. Also, Tom, the chairman of the board of SunSpec Alliance, presented there at the V2G forum on cybersecurity and essential topics and the set of requirements for 2026. So yeah, so all good, exciting news there. With that, let's go ahead and get to some of these questions. Starting off, I'm just going to go from the top down. I think I did see some people respond already. I did
respond to a few, yeah.
Okay. Starting with the question 1. Question to James.
Oh, George. So I think Dave is the next one.
Oh, George's question already got responded to in chat?
Yes.
Okay. Let's go to Dave Kaiser's question. James, how does UL 3141 PCS fit into your safety matrix?
So I actually don't know that much about 3141. We haven't been involved in it. It's, if I understand correctly, it's primarily a hardware specification for a switch to island a residence from the grid. And in that case, that's what enables vehicle to home happening. So that's my understanding. If I'm wrong in that, someone please correct me. But so we don't pay too much attention to it in the V2G world. Although you're quite correct that it could right now it's part of it in the sense that if you want to do V2G in California, V2G AC, you got to have some sort of a switch to get off of the grid before you energize your house. And or before you do any V2G AC communications. Hope that works.
Great. Thanks, James. Next question from Rudy Albright. Why would the cost of interconnection be different between AC and DC? He doesn't believe it will be in California.
Oh, that's really helpful feedback, Rudy. I wish you'd been in Detroit last week because I put up those slides primarily, with the intent of getting feedback to see if they were accurate. I actually don't know that, and I didn't ask chat why it did that. But you, as a utility person, if you're saying that it shouldn't be different, then that's really interesting.
And feel free to comment, Rudy, if you'd like. Sorry, James.
What was that?
I just said, Rudy, feel free to come off mute and comment if you'd like with James. No worries if not. Sorry to interrupt you there, James.
No problem. Thanks for the comment, Rudy.
Sorry, I'm a little slow to do it. I'm not used to this this app, but I'm just checking with Kristen, who I think was there, Kristen Landry from PG&E, but to see if she thinks if I'm missing anything. She's our expert in interconnection on our team, but the process, you know, I think the real question mark is, will we be able to overall reduce the cost of interconnection, which we're certainly wanting to do. So it shouldn't be more expensive than your solar, for example.
Well, my understanding is the interconnection and the whole EV V2G residential is sort of built around solar, which is a different kind of business model and a different economic model. Someone was telling me about it, that solar, you know, you've got a $40 or $50 or $60,000 rooftop solar, and so you can have, you know, paneling and stuff that's $3,000 or $4,000, and it's sort of higher end. But with V2G, you really do want to get those costs down, especially in the AC side. So
right, because I mean, traditionally it's changing now, but with NEM, you didn't really pay that full cost. A lot of it was covered. And it's also a question of whether it's, so right now it's $800 for the initial interconnection. And for many customers, that's all you'll need to pay. If there's a secondary study that's involved, which depending on where you're located and the complexities on that point of the grid may or may not be added, that could be another $2,500, which starts to get quite prohibitive.
great. Thanks, Rudy. Appreciate your comment.
Yeah, thanks, Rudy. The next question comes from David Rodriguez. What's the cost delta of a V2G AC capable vehicle? Which EV support it today?
Let's see if I've got this up here. I asked some of the vehicle guys that were at the V2G forum about this, and then they said this is probably about right. You know, what you're looking at is an inverter. One of the interesting things that I've always thought about, thinking about the auto guys putting the inverters in the autos versus putting them in a charging station, is that the auto guys know how to mass produce stuff and know how to engineer costs out of it, and so you know, they'll get the costs down as far as possible because of the resources they can put into it. This $300 is not too bad. It goes up if you get bigger, you know, bigger inverters, obviously. But people that I talked to, you know, kind of nodded and said, yeah, not too far off. And none of the EV guys will, you know, actually publicly tell you what the cost is. But you know, there's some people there. In terms of who's doing this, so Honda is talking about doing it. They had somebody presenting. Lucid already has onboard an inverter and is a very big proponent of this. Tesla has it. The Hyundai Ioniq 5, the high-end one, has V2G capabilities in it. And from personal experience, we know that almost all the automakers are either actively doing development or planning to, because they see this coming. Okay.
Awesome, thanks.
Just commenting on my comment that follows that. Have you heard any indication that they're going to offer that as an option and pass the cost through to the customer? Or is that just going to be ubiquitous through that line of vehicles once they've added it, which is kind of what I would tend to think.
Well, I think that's still to be determined, right? So we had a really interesting guy. I don't know if you know him, Rudy, Anthony Martin from Lucid. He came out of Ford after about 10 years, but he had him on a panel, and he and I forget his name, one of your guys was there, and they kind of went back and forth on, you know, what's the value to consumers of being able to do V2G, right? And so, you know, I know you're working on this, but everyone's kind of scratching their heads and saying, so what are the business models that make sense? You know, if it becomes standard so that every vehicle, you know, it has it in and it's priced that way, you know, with it in, that's one thing. If it's an option, that vehicle manufacturers charge an upgrade price for, like Hyundai does. Then it gives consumers the option of checking with the utility. Do you have a program? And what can I do with this? And it's probably also then paired with an option to do battery backup store for the home, right? Emergency battery backup, which is a real, valuable use case for a lot of people.
Right, but I'm thinking of the inverter in the Lucids, in the Tesla Cybertruck, and now in the new Model Y Performance. And I don't think that in any of those cases they offer an option to save X amount of money by not having that, unless the low-end Cybertruck might strip that. I'm not sure, but I don't know if they stripped the inverter out, but they stripped a bunch of things. I know they stripped out the external power maybe. There's something that they took out. I don't remember very well, but in any case, no one's going to buy that low-end one probably anyway, from what I've heard. But I see it as just being part of the pricing of the vehicle. I don't think it makes sense for them in a quantity production for a $300 item to offer it with and without, unless of course they do a software enablement and charge you for it.
Yeah, so that's a good comment, and that would be great. If you have that, then you have a really great ecosystem, and all we have to do is get everything to work together, right, Rudy?
Right.
So, okay.
I mean, if you look at the cost of using your vehicle battery especially if you're looking at it for an exceptional backup event at the minimum, compared to, having Tesla or other Powerwall type products installed, I mean, it's just always going to be a lower cost to get that amount of storage, because otherwise you're looking at, many batteries in a huge bank to try to get what your vehicle can provide. But of course, if you want something while you're going to be away for 3 days doing road trips while the rest of your family's home, then it's a different model. So not everybody's the same, but I think for those who it works for, certainly in my case, I wouldn't choose to get Powerwalls over my vehicle.
Yeah, I think that's great. So great comment. All right, so what else do we have?
Yeah, so I think try to squeeze one more question in here. We got quite a few more, so we'll try to do our best to follow up with everybody to resolve those, or we can stick around if James is up for it. But I'll go ahead and ask this next question in line from my friend Vishganti. Which standard is ideal for flexible service connections, or Flex Connect, at EV fleet depots and microgrids, especially between grid DERMS to edge controllers, site level?
So that's a really interesting question, and I think the California utilities are sort of rethinking this whole flexible resource position. Historically, anything that had to do with demand management was probably done with an open ADR protocol to the aggregator or to the energy management system or fleet management system or something like that. And in Europe, that's actually going really well. Open ADR is very popular in Europe and being used there, and in Japan. But if you want to add to it the management of devices, EVs, as grid resources and vehicle to grid, then you're not going to do that with open ADR. You have to have an IEEE 2030.5, which could also manage the demand management side of things. And so I think that's where we're headed, is because it's a more developed protocol from a DER management standpoint. And if you want to have that flexibility of managing resources as either flexible loads or as DERs, then you probably move to a 2030.5. I hope that answers the question you were asking.
Yeah, absolutely, James. Yeah, I mean, in the context that there is a DR event function set or what have you, but the CSIP doesn't call for using it. So
no, but we're working on CSIP 2. And if utilities are thinking this way, then you start adding some new features, right? Or start adding some new function sets to CSIP, for instance. So we'll see what happens with that. And we've been hearing from utilities and aggregators this question for a long time, and our answer has always been, if you want to do just management of demand, OpenADR is perfectly fine. If you want to combine that with DER management, you probably need to either do both or do it with 23.5.
Yeah, particularly in the context of these flexible service connections, it's an interconnection type. So there is grid codes involved. It's not just an aggregator demand response where you're sending events to curtail, right? These are explicitly complying with the interconnection rules for flexible service connections.
That's actually not something I understand very well, Vish. So could you point me at something that could help me?
So I did a webinar with PG&E. Actually, SunSpec hosted a webinar about 3-4 months ago on Flex Connect, where we talked about it, but at a very high level. And then the commands that are used are what's popular in the OS CCIP OS, the dynamic operating envelopes and stuff.
Okay. I know we're involved with that. I'm just not personally that involved with it. So thank you, Vish. I appreciate the comment.
Sure.
All right, we are now past time, and I'm seeing people are starting to trickle away. So let's go ahead and wrap up. James, if you can go to the second to last slide, we can just look ahead to the next webinars in this series. So thanks everybody for your time and attention today. Next up in the 6-part webinar series, we are going to, looks like this is out of order. Sam, which ones?
It'll be Damon Catcher with Secure G going over PKI on November 11th.
Perfect. November 11th with Damon Catcher of Secure G, who is our 2030.5 PKI infrastructure provider. We'll be talking about, obviously, PKI, and also I think he wants to look ahead to the impact of quantum computing in cybersecurity and public key infrastructure as well. So November 11th, come back and to hear what Damon has to say. And thanks again so much to James and Steve. Really great and informational content and webinar here, and thank you for your continued support and contributions to the Alliance and the industry as a whole. So with that, we thank you for your time.
Thank
Have
you.
a great rest of your day.
Thank you.
Thank you.
Take care, everybody.
Thank you very much.
Bye-bye.